Hello, everyone. My name is Aanchal Malhotra, and I lead research at RippleX. I've been with Ripple for a little over 6 years now. My work here sits at the intersection of cryptography and blockchain infrastructure. And right now, I'm focused on a few big bets: compliant privacy, post quantum security, and really the core fundamentals that make XRP Ledger ready for what's coming next. Before moving on, I want to say that I'm extremely gutted that I couldn't be there in person. I was really looking forward to this event. However, I'm still very excited for the opportunity to address this room today. And I want to thank the organizers, specifically Vera, for making this exception and letting me present virtually. All right, let's dive into it. I'd like to start by saying where I see this space is headed from the lens of a researcher who works on the live ledger every day. We are all aware that the XRP ledger has been settling real value since 2012. The foundation is proven, real adoption is happening. Institutions, regulated issuers, payment corridors. So the question, can this work, has been answered. But adoption raises the bar. We are not speculating about what blockchain might do. We are being asked to do harder things by people who are already here. So, in my opinion, four forces are converging around that raised bar. The first is the institutional adoption, and it is surfacing real requirements that didn't exist at scale before. So, things like privacy, compliance native infrastructure, and reliable auditability. These are not future feature requests, these are the conditions for the next wave. The second is the technology itself, specifically cryptography. So, the cryptographic tools, really powerful tools such as ZK proofs and post quantum signatures, are catching up. They used to be academic papers a decade ago, but as we all know, they are deployable primitives today. So, the gap between what researchers can prove and what engineers can ship is closing, and that's new. The third is AI, and AI cuts both ways. It provides new capabilities for builders, but it also comes with new threats for security and also a entirely new class of participants. And I'll spend some real time on this as it touches every working group today. The fourth is the regulatory clarity, which is arriving. So the frameworks being written right now will shape this space for a decade. That's an opportunity, not a constraint, if the people building the technology are in the room. So, this is the moment, not because of hype, but because of convergence of these forces that's changing the narrative for on chain finance. Privacy. Almost every conversation in this space hits the same apparent tension: privacy versus compliance. But I would like to reframe it. Privacy itself is not the enemy, opacity is. These are not the same things. So, debacles like Alameda, Celsius, FTX, every one of those collapses had opacity as a structural precondition. So, the question, how much is really there, was unanswerable until the answer became zero. And that's a failure of architecture. Because systems that hide everything from everyone, including auditors, including regulators, are not privacy preserving systems. They are opacity machines. So, in my opinion, financial systems really need three things. And they might look like they are in tension, but they are not. So, the first is the actor privacy: who holds what, how much is moving. This is legitimately sensitive information. Institutions at scale cannot have their positions exposed to the market. This is real, And it is one of the primary reasons regulated institutions have been slow to move on to public ledgers. Second is the market integrity. So questions like, can supply claims be verified? Can anyone confirm the rules are being followed? This is the mechanism of market trust, and it's definitely non-negotiable. Third is the independent auditability. Regulators and auditors need to verify, not trust, with their own access on every transaction, not depending on what an issuer chooses. Tying it back to XRP Ledger, this is what confidential MPTs on XRPL does. Balances and transfer amounts are encrypted. Aggregate supply stays public. Auditors receive cryptographically enforced access on every transaction, not a request. The mathematical insight that zero knowledge proofs make possible is that you can prove something is true without revealing the underlying data. So an auditor can verify that every transaction respected a supply cap without seeing individual balances. A regulator can confirm compliance rules were followed without accessing private positions. The oversight is stronger because it is cryptographically enforced rather than self-reported. Now, that is one primitive, but it's not the whole answer. The next layer, hiding who transacts, not just how much, is where the active research is right now. So, for the researchers and engineers in the room, the open problems here are very significant. Anonymous credentials, selective disclosure, identity preserving compliance proofs. If you're working in this space, this is the collaboration worth having today. Programmability. I'd like to spend some time on this because I think it's important to address in XRPL's context. So XRPL was designed with a very, very clear purpose: fast, low cost, reliable settlement. And that focus is deliberate. However, as the ecosystem grows, how do you extend what XRP Ledger can do without compromising what it already does well? RippleX is trying to answer these two answers at two different layers. So the first is native programmability at L1. So things like features like smart escrows that allow release conditions to be expressed as code. The important thing is that it is bounded by design and it operates within the fixed model. So security is top of mind. And second is the extension chains, which I define as execution environments above L1. The key there is that these chains inherit XRP Ledger's security through ZK secured, trust minimized bridging. A bridge secured by trusted operators requires trusting those operators. A ZK secured bridge requires no such trust. Anyone can verify, no operator can override. But what does this unlock? So, use cases that have no home on L1 today, such as complex programmable confidentiality, complex multi-party workflows, some kinds of agentic payment execution, all of this can run on extension chains while settling back to XRPL mainnet. Assets stay anchored to L1, security flows from L1, XRP remains the settlement asset. And this is not just a roadmap, the work is already underway. So BN254 elliptic curve precompiles are live on XRPL DevNet. ZK verifier independently audited. Smart vaults are in active specifications, and the real work is in progress. So for researchers and engineers in the room, the composability layer, where extension chains interact with live XRPL state, is the harder phase and where the most interesting open problems live. Next is AI. AI, I think, is the force in this conversation that is most underestimated. Not in terms of attention, it gets plenty of that, but in terms of what it actually means for public infrastructure like XRPL. So I'd like to talk about AI from three angles today. First, AI as a participant. Autonomous agents transacting on public infrastructure are coming. Early forms exist today. And what do they need? They need privacy, they need finality, and they need verifiability. And ZK proofs are really central to that last requirement. An agent whose behavior is cryptographically anchored to auditable rules is one where autonomy and accountability can coexist. Apart from this, there are the governance questions, such as who is responsible when an agent misbehaves, how do you regulate a participant with no legal personhood. These are equally unsolved and equally urgent problems. Second is AI as an adversary, and this is the angle the industry is most underweight on. Attackers now have AI assisted vulnerability discovery, automated exploit generation, and social engineering at a scale and speed that manual security processes cannot match. So, the dominant security model of build, audit, ship, react is not keeping up. One recent incident, nearly $300 million lost, zero bugs in the smart contract code. The failure was a configuration decision that sat entirely outside every audit ever run. AI accelerates the attacker side of this equation. So the defense has to shift too. And that brings me to the third angle, which is defense. So in terms of defense, two shifts need to happen. First is the continuous AI assisted monitoring, meaning ongoing adversarial examination of live systems, not periodic reviews. And second is the AI accelerated formal verification, meaning mathematically proving that a system behaves correctly, not just that it passes certain tests. That is the direction we are heading, and that's where the most important defensive security work of the next decade will happen. So, for educators and students and researchers in the room, the intersection of AI and cryptographic security is one of the most open, most consequential research areas right now. The field genuinely needs more people working on it. Next, I would like to talk about post quantum, because why not? All right, let me talk about this because I think this is something the industry knows it needs to deal with, but keeps finding reasons to postpone. Quantum computing will, at some point, be able to break the cryptography that secures most blockchain accounts today. Not in a theoretical, distant future way, but in a measurable, compressing timeline way. So Google published research in 2025 showing the requirement had dropped 20 times in 6 years. That estimate keeps improving. Nobody knows the exact date, but the direction is clear. Here's the framing I find useful. The cost of being early is small. You spend time preparing. The cost of being late is catastrophic. There is no patch. There is no recovery. For a public ledger handling real value, that asymmetry makes the decision straightforward. And really, it's not just the technical question. Regulators are already moving. Major standards bodies are deprecating the cryptography most systems currently use by 2030. So, for any ledger that takes institutional adoption seriously, being behind that clock is not an option. Now, for XRP Ledger, the good news, and there is real good news there, that XRP Ledger's design gives us a better starting position than most. So, features like key rotation have been built into every account since 2012. So, when post quantum signatures are ready to deploy, accounts can migrate cleanly and safely. That capability exists today on XRPL. It doesn't on many other major chains. On the post quantum standard side, they also exist now. The work ahead is integrating them carefully, making sure performance holds under real conditions, and coordinating the ecosystem. That's real task. So, ecosystem including wallets, exchanges, custodians, coordinating them through the migration is the hard part. It's not just the cryptography. Ecosystem coordination is the real hard work. But this is the signature part that's relatively easier. I'd also like to be honest about what isn't solved yet. So, the encrypted state, like the confidential token transfers I described earlier, faces a related but slightly distinct challenge. And that's active research, and we say so openly. Overall, the bottom line is we are not waiting, the work is underway, and the design choices made in 2012 are turning out to be exactly the right ones for a migration like this. So, again, for the researchers and engineers in the room, performance at consensus scale, fee model redesign, formal verification of hybrid schemes. The open problems are real. All right, this brings me to my last slide, and I'd like to bring this all together. Everything I've described today, privacy that regulators can trust, programmability that extends without compromising, infrastructure ready for AI agents, cryptography built for the next decade. This is not a roadmap, it's real work in progress, real research, real code, real conversations with real institutions and regulators happening right now. The XRP ledger is 12 years old. It was built with clarity of purpose, fast, neutral, reliable settlement. The adoption is real, the foundation has held up, and the work of the next decade is extending that foundation carefully with the same discipline that made it work in the first place. That extension doesn't happen in a single team or organization, it happens in rooms like this one. So the working groups today are not just parallel tracks, they are the same problem from different angles. You cannot write sound interoperability standards without understanding the trust assumptions of the underlying cryptography. You cannot design AI governance without understanding how verifiable computation anchors agent behavior to auditable rules. So, to everyone in the room, specifically to the researchers and the engineers, the open problems are real and significant. The work is happening on a live system that moves real value, and that's a rare opportunity. The hardest part of, I'd like to conclude by saying the hardest part of this work isn't predicting the future. It's choosing what to build today, knowing the future will be shaped by those choices. Look around this room. This is exactly who should be making those choices. That's it. Thank you. Thanks everyone for listening and hope you have great 2 days.